朱少华，你那个有没有装 Mac Power 啊？你那个 MATLAB 上面有没有装 Mac Power？ 你没有装是吧？你不急。好，行，好，我来讲吧，好，可以。OK. The firstly that we have looked at the task one. Task one is to carry out the power flow calculation using MATPower. MATPower can be downloaded from the source. I'm not sure if this link is still available because
this is not available.
It's not because I assume
this is for version 4.
Yeah.
But now it's still at 7.1.
Yeah. Now I will teach you hand by hand how to add the MATPower to your MATLAB. Firstly, let's open the MATLAB software. Then click this button, set path. Then you can use. I show them one day before. Now I show you another time because for this time the MATLAB is in the English version, so it's better for you to understand the languages. I will only show you this time, okay? Remember. Then add the MATPower. Add them with subfolders because MATPower it has many subfolders. I install my MATPower in the MATLAB documents. When you download MATPower, put it in one document that you can remember. Then add them to your MATLAB. I have the MATPower 4 and MATPower 5. I have two different versions. You can install any of them for your convenience. Okay, for me then select this. Okay, then click. You can see here all these documents. These are the folders and subfolders for the MATPower toolbox. Then we add them in my MATPower. Click save button. Then click close. Now let me have a look to see if the MATPower is being installed here. I cannot find them.
But you can write test method.
Sorry?
Test method.
Yeah, test MATPower. It's not my laptop, so I'm not familiar. Test MATPower.
Yes.
Okay.
Underscore. We have underscore.
Okay, sorry.
No. Can I come?
Yeah, okay, you can hear. Yeah, it's coming.
Is there some time?
Okay, it just takes some time. Okay, then try to put this command on the command window. If we see those lines, the commit lines, it means that we have already successfully installed the MATPower in the laptop. Okay. We have the different solvers for the MATPower, like the LinProp, the quadratic form, and the DCOPF and OPF. We have different solvers. Okay. But how do I find where is the MATPower toolbox? have already done the first task. We already got 3 marks. Then let's have a look at the question A. We have the 9-bar system. When we download the Math Power, here let's have a look at here. Okay. No. When we take a look at the Math Power profiles now, because last time Tang Jin told me where can we find the 9-bar data.
Yeah.
If you take a look at the Math Power profiles, it already gives you a lot of test system, including the small system like 4-bar system to 300-bar system. If you have interest in, you can test the data. You can use the systems. All of the systems can be used to test the data. You can run power flow. You can change the values of the different bus. You can modify the active power or reactive power for each bus. Then we can see the difference. We can see the different results of running power flow.
Yes.
It can help you to understand the concept of the power flow. Now we can open the case 9, the case 9 profile.
I tested 33 buses.
23.
33.
Yeah.
But this Math Power 5, no 33. Math Power 7 have a lot of buses.
Because it's not my computer, so it may take quite a long time for me to get familiar with this. Sorry. Next time I will bring my own laptop. Why do we open so many MATLAB? Now this is the case 9 profile. You can see when we want to read the system in MATLAB. Firstly, we have to install them. We have to install them as a function. Sorry. Slow. We have to install them as a function in the beginning line. We can use the term function MPC equals to case 9. Then we can write them in this format so that the MATLAB can read the information. Now we can see the power flow data. The system, the M-base system is 100, and then for the 9-bar system, this is the benchmark system. This is the configuration for the 9-bar system. We can see that for the 9-bar system, we have 3 generators: generator 1, generator 2, generator 3. Then we have the load. We have the load here, load A, load B, we have the load demand for the rest of the six nodes. This is the configuration of the 9-bar system. When we have this system, we don't know the data. We don't know the specific data like the generation data and the load data for the 9-bar system. Then we take a look at the Math Power profile. Here we have the bus data. We have now we see we have 9 buses because we have nine nodes, so we have 9 buses. For the bus 1, one is called the swing bus, the slack bus. It's also known as the slack bus. No, it's okay. You can see here. It's already dry. Sorry. It's already dry. It's like the slack bus, and for the bus 2 and bus 3, because it's the generation bus, so it's the second one. It's a PV bus. And for the bus 4 to bus 9, it didn't have any generation. It can only consume the load demand, so it's called the PQ bus. Yeah. PQ bus. Now
PQ bus is load bus.
Yeah, PQ bus. Yeah. For this information, now you can understand the. You can answer the questions for the question A. Which one is swing bus? Swing bus is bus 1. Yeah. Okay. Which one is the PQ bus and which one is the PV bus?
2, 3 and bus
and the rest of
this is the PQ bus.
Okay, now
7, 9 and 5 is PV bus.
Yeah, okay. By looking at the profile, you can read the information. The first row is the number of the bus. The second row is the different type of the bus. And for the third row is the load demand. The third row is the active load demand for each bus. And the first row is the reactive load demand for each bus. Then this is the weighted profiles and the base kilowatts weighted profiles. Now let's look at the generator data. For the 9-bus system, we have 3 generators. Generator 1, generator 2, and the generator 3. For each generator, we have the different capacity, the maximum generation and the minimal generation. Yeah. For bus 1, the maximum for bus 2, the generation is 167, and for bus 3 is 85. Now this is the different data. Also, for the 9-bus system, we have different branches. The branch connecting different nodes. Now we see we have branch 1 for connecting bus 1 to node 1 to node 4, and then for branch connecting node 4 to node 5, we have this branch. For this system, how many branches? 9 nodes. How many branches?
9 of.
Now let's have a look at the mad power profile.
9. Branch is 9.
Yeah. You can try to count them, or you can write down themselves.
Branch
1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. The first branch is the branch connecting bus 1 to bus 4, and the second one is connecting bus 5 to bus 5, 4 to bus 5. The third one is connecting bus 5 to bus 6. See, it's easy. Yeah. By writing this profile, now we install all the information for the branch. For the branch data, we have the resistance, the reactance, and the it is the RXP. Yeah, you can write here in the third, fourth, and the fifth row of this data. Also, we have the ratio and the angle information. Now, this is the basic information for our system. You have to put the bus data, generator data, and the branch data. Then for the rest of the system, it is the generation cost data. We put the generation cost because each different generator has a different generation cost. It has the different values of A, B, and C. Yeah, this is the different value for A, B, and C. You see here, this row, the third row. The last 3 row refers to the different data for the generation. Okay. Now we have the 9-bus system, and then we have already installed mad power. What for us? What for we next to do? We run the mad power we use mad power to run the power flow. Now I can show you how to do this, or you can write a function. The easy one, first one. No. Load. I'm not familiar with his laptop. Yeah, load quiz. Just write this one comment, then the MATLAB can read the information for the case 9 system. It means the answer then you can have the information. We have 9 buses, we have 3 generators, then we have 9 branches. It's the brief summary for the 9 bus system. Then just run one command.
MC. Case 9. Okay.
Okay, run case 9. Now here this is the result. This is the result. It's used now. We can say it's using the Newton-Raphson method. You don't have to take a long time to calculate the power flow. Just using one command, then you have the power flow result. It can converge in only 4 iterations and only takes 0.2 seconds. Now this is the system summary. How many buses, how many generators, how many loads. This you already know because we don't have the shop. Then so we don't have the transformers. Then how much generation capacity for how many online capacity, how many generations, how many loads, and here we can have a look for the small system, for the 9-bus transmission system. What we have to focus on? We have to focus on the power system losses because the losses is the key to for us to determine whether the system is economic or efficiency to transfer power flow. The losses here, 4.95 megawatts for this system. Now this is the weighted magnitude for the system. For the 9-bus system, the maximum power weighted profile is 1.003 per unit, and the minimum value is 0.958. Yeah, okay. Now we can see the data. You can see the data here. For this system, we only have 350 megawatts load demand, and for generator 1, it has to provide 71 and 95 megawatts. For bus 2, 163. For bus 3, 85. Because for the generator 1, it only provides the minimal value of the generation 1. Why generator 1 provides the minimal value of generation, and bus generator 2 and generator 3 provide more than generator 1. Have you considered this before?
For load?
Yeah.
For load?
No, because generator 1 is more expensive. For the economic concern, the system operator always want to using the cheaper one. You see here, yeah, for generator 1 it's more expensive. Yeah, for generator 2 it's not that expensive, okay?
But generator 3 is also expensive, man.
We can analyze the rest of them, then you will know. Okay, so this is the branch data. The branch data, you can see the power flow from each branch, from node 1 to node 4, from node 4 to node 5. And then this is the losses. This is the losses for the whole system. The power losses is 4.955 megawatts. Okay, now we complete task 1. Do you understand it? For the rest 4 of you, I already show you how to do the homework. When we finish our class, go back to your home and do it on your laptop and try to summarize it in Word format and email to me. Okay, email to me by the end of this practice. This is task 1. Now let's have a look at the task B. Task B is Now we have the 9-bus system. We have 9 branches. It has in task B, we have to add one transmission line connecting bus 7 and bus 5. Connecting this one, adding one line together, connecting these two loads, and calculate the power flow again. This is the line data because when we add a line, we must provide the reactance, the resistance data of this line. This is the data, and then we compare the difference of the original system configurations. Now let me show you how to do this. Firstly, we copy this profile because it's the branch data. Then we put it in the 9-bus system. We put in the branch data. We add them at the bottom of the branch data. Yeah. Of the branch data line here. Then click save. Now we run this data again. Change the folder. Then we run PF again. Here we have the different value of the power losses. Now let's have a look at this. For the task B, the system is more or less the same. We have also 9 buses. 3 generators, but we have the 10 branches because we're adding one branch between bus 7 and bus 5. Now we have 10 branches. We can find the results here. The power losses become small. It's much cheaper and efficiency for the system operator. Why? We can see why. I asked you to analyze the reason why. Have you considered this?
For extra branches.
Sorry?
Our losses.
Why the losses is small?
The 48, 47. Because we add this one extra branch.
Okay, I will analyze this in detail. Now we can see the weighted magnitude. The minimum weighted magnitude is also changed. It decreasing to 0.966. And for the maximum power profile, it increases. The maximum weighted profile increases to 1.011. Here we can see the generation. The generation is the same. The same. Why did the power loss changes? Because we can see that for this system, we only bus 5, bus 7, bus 9 have the load demand. And for the system, the generator 1, it provides the minimum generation because it is expensive. So and here we have the 2 load demand here. We have 2 load demand here, but only 1 generation resources. If we want to satisfy the load demand, then we have to transmit power from generator 2, generator 3 to bus 9 and bus 5. We have to transfer power from here and here. And for this line, we only have 1 load demand that is in bus 7, but we have 2 generators to provide the generation, that is generator 2 and generator 3. So this is the waste of the power, because in this section, we only have 1 load demand, but we have 2 generators. But for this section, we have 2 load demand, but we only have 1 generator. To satisfy the system generation and demand, we have to transfer power from here to here. If we're adding 1 line here, then there is power flow from bus 7 to bus 5. From bus 7 to bus 5, then we do not have to transfer that amount of power as original from generator 2 and generator 3. So that the power losses is decreased. Is that clear? Now we can see the branch data. The power transferred from bus 7 to bus 5. For here the power is positive. It means it transfer power from bus 7 to bus 5 is positive. Then the load demand in the bus 5 is supplied from bus 7, because bus 7 for bus 7 here it has enough power demand. It can also transfer power here. So we don't need to transfer power here from generator 3 to generator 5. Then the power losses is decreased. Is that clear? Okay, now let's have a look at question C. We can find that the load here, we only have 3 loads here. Load 5, load 7, and load 9. The task C is to increase the load at bus 7 to 330 MW and 400 MW, and calculate the power flow again. Then provide the voltage profile of each bus and the total power loss. Compare and compare the difference. Explain the difference of the readout with the original system configurations. Next time for you to bring the Word format document, you do not have to write down, okay? Because when you submit the Word format, you can copy the results here in MATLAB directly to the Word profile. It's much easier for you, okay? Now I will show you how to change the profile. It has to change the profile here in bus 7. We change the active and reactive load demand here. Change the value from 100 to 330.
No, not this one.
Oh.
This PD, this is the real power. This one is 100. This is the type of power.
No. Oh, yeah, okay, sorry.
This is the real power. Yes.
No, this is this value, yeah, it's okay. For the type, this one refers to the type, this one refers to the active power. Yeah, change this to 330 and this to 40. For the bus 7, to increase the load demand at bus 7, the total system load demand is increased. Now we run the system again to see the max power profile. The value is changed. Now let's have a look at the system summary. Okay? Tang Jing. Sorry. Take a look at the screen. Okay? I will show you, because this is the first task. I will teach you hand by hand how to solve the task. Okay? For this system, we also have the 9 buses, 3 generators, and 10 branches. But the generation is changing, and because the load demand is changed. For the original system, we only have the 315 load demand. But for this one, because we increase the load demand at bus 7, now we have 50 and 60, 500 and 600 load, 50 and 45 load demand. And then adding the losses, we have to generate 560 generation to satisfy the load demand and system losses. Why the losses becoming so large? Can you explain it? Have you solved this before?
Can you ask me this question again, please?
Sorry?
Can you tell this question again, please? This question.
This question?
Yeah. What I explained.
Okay. I will show you. Okay. Also, the weighted profiles we change. The buses at the weighted at bus 7 is the smallest one. It's beyond the it's below the given range, because for the given range the weighted value is to 0.95 per unit, and for the bus here is below the given range, and for the maximum value is still as the bus 1 is the one per unit. Here this is the generation, because the load demand is increased, and for generator 2 and generator 3. For generator 2 and generator 3, the maximum generation value is 163 and 84 megawatt. If the load demand is increased, we can only use generator 1 to generate more power, because generator 2 and generators cannot provide excess power. So if the load demand increases, all the excess energy generation has to be provided by generator 1. So here the generation profiles for generator 1 increase to 312 megawatts. Is it clear? This one is increased but for bus 2 and bus 3 it remains the same. Okay? So for the load demand, bus 7 now it has a maximum load demand. The load demand here is 330 megawatts. Here we can see that for the branch data, because bus 7 has we can analyze which loss is the largest for the 10 branches. Here for branch 4 to branch 5, the loss is the largest, 5.558 here. And for the branch bus 7 to bus 5, the loss is the largest, 725. Let's see why. Because all the load demand increase at bus 7 has to be provided by generator 1. Then how the power flow from here to bus 7? How does what's the direction of the power flow from here to here?
This bus 1 to 4, 4 to 5, 5 to 7.
Yeah, because the power flow has to because I don't have a pen. Yeah. The power flow has to flow from this direction, from bus 1 to bus 4, then bus 4 to bus 7, then bus 5 to bus 7. Yeah. The load demand profile is increased for nearly 200 megawatts. So this power flow from here to here to here, from this direction, so that the power losses through this direction is becoming larger, like 5.582 and 3.573. Okay. Now let's have a look at here. Because for this direction, why this value is negative?
Our generator loss, see, this generator 1, our power flow is just from generator 1.
Yeah, because for this one,
this is the opposite direction.
The different direction. You understand? Okay.
This coming to 5 to 7, but it's going to 7 to 5.
Yeah. Okay. Because for the map profile processor, here bus 7 is put here first, because it means the power flow from 7 to 5. But here, when we take a look at this picture, it means that the power flow is from bus 5 to bus 7, so that the direction is reversed, so that the value is negative for the power flow data. Here is the main difference. There are 3 differences. First one, the generation differences, and then the weightage differences. Why the weighted magnitude at the bus 7 is the lowest? Because bus 7 has the maximum load demand in the system. All the power flow has to flow from other generators to bus 7, so that the weighted magnitude at bus 7 is the lowest. Okay? This is the reason why. This one is the slowest, okay?
Can you just tell one second, please?
Because the load demand at bus 7 is the largest. All the power flow has to flow from other directions to bus 7. The load demand is very large, so that the voltage profile here is low. Okay, this is number 2 difference for task C. Then number 3 difference is the losses, the power losses. The power losses, there are 2 branches. The first branch, branch 4 to branch 5. The second branch, branch 7 to branch 5. The 2 branches we need to take a look. The third difference for the task C. The power loss is different. The first branch from branch 4 to branch 5, the loss is very large. And the second branch from branch 7 to branch 5, the power loss is large. Okay? This is the difference we need to compare and analyze. Clear? Is it clear so far? Now we have already completed all the lab 1, the task 1, power flow. It's simple, right? It's simple because we do not need to write the command. All you have to do is to familiar with how to use MATLAB, how to install MATPower, then how to use MATPower to running power flow. Just one command, run PF, okay? Maybe you can, I assume you too understand the contents. Okay? This is for the task 1. Now this day is Thursday. For the next 3 days, the rest of you finish the homework. Next Tuesday, come to me. Bring your laptop and the word profile. The reports for lab 1. Okay? For task 1. For task 1 for lab 1. Then next week, we will continue the study for economic dispatch. Yeah, for Tangjing, you already have finished, but I don't know if you have the explanation. Do you have to adding some?
Yeah,
adding some reports. Yeah,
analysis.
for analysis because
every experiment has something to analysis.
It's not just a generation. You have to analyze why the loss is becoming so huge. Yeah, okay. Analyze, adding some details.
I mean, this every data after I add some this manner.
Maybe if you have time, you can also prepare a Word format report. Okay.
Yeah,
okay.
And this is my new line.
It's very good because by drawing this line, it can help you with how the power flow direction. It can help you familiar with the power flow direction. Then for next week, we will discuss the economic dispatch. If you have time, like Tangjing, if you have time, you can take a look at the reference book I give you, okay?
Okay. And for overseas student, we need this word.
Sorry?
Who is not in China? For them, we need this word, right?
Huh?
Who is not in China? I mean,
not in China.
My classmate who is not in here.
Yeah.
They have to do this homework or not?
I hope they can do this, and then they can send me the work profiles. Yeah, I can take a look at the homework. Okay.
But ma'am, for that homework we need this
PDF.
The Word format, PDF reference book you can give them, and for the Word format. This one I can give you, okay? I can give you. Wait a minute. Do you bring your USB? Yeah, I can copy it.
Because
so next Tuesday, come here. Directly come here, okay?
Okay,
come here. Bring your laptop. Bring your laptop.
Could you please give your email the student how can send you?
I will give you my email address in the group way chat, okay?
Okay. ওয়ার্ড তো সমস্যা হয়ে যাবে আমার প্রচুর।
Okay.
তো কপি হয় না ঠিকঠাক ভাবে ওয়ার্ডে, সব কোড লিখে লেখা যাবে বুঝতে, তারপরে তোমার ওয়ার্ড ফাইল বানাতে হবে।
I give you my email address in the group WeChat. Okay. Thank you. Because this is my first time for giving you the license here. Right. Okay. Thank you.
Last time Miss Pongla she said me who is not in China, when they will come they will do this class. That's why I didn't tell anything.
Okay. If they want to join the WeChat group, they can join the WeChat group.
Okay.
Okay.
But I think lastly this is also a bit difficult for them to do this homework.
How about them do the homework for other classes?
They did, but especially for this course now it's
Maybe I can give them the classes next year for the next year class. But you can send them radio.
Yeah, I can send them video. They will come maybe next year. So you can give them class next year, Lashi.
I will discuss this with Peng Yuzhu, okay?
Okay, Lashi. So Lashi, it is when you will discuss after tell me, because after your discussion we will send them that they will have to do or not.
Okay. Yeah. It's up to you to them. Yeah, I know. Yeah.
Because Lashi, now is the time no one have like this MATLAB or something.
But they have the internet. They have the computer.
Yes, Lashi, I understand everything like this.
Okay.
So you can talk with Miss Pongla. I will send them this video.
Okay.
And after that we can take. After that we can make sure we will send it to them or not.
Okay.
Okay, ma'am.
Oh, okay.
Because this course is important for them. Ma'am, can you just look?
Sorry?
Can you just look? Right. This is I made 3 profiles. This is question A, and for A, this is question B. For B, I add this one.
Yes.
And this is my question C.
Yeah, okay.
For
It's good.
C, I add this verse 7, 340. And this is my answer data.
Yeah, this is the answer data.
This verse. So should I have to add also this one in one file?
It's up to you. Just the result here is okay. I think just the summary data is okay.
Okay.
Yeah, because it's clear enough. Thank you.